All right. So we're gonna do the quizzy thingy.
Yeah.
All right. All right. Starting. Okay. Wait. Why is it repeating?
What's repeating?
Oh wait. I don't know what my computer's doing. Oh. Okay. Hold on a second. I think I have two going on at one time. Oops. Oh, technology.
We get to learn a lot about it as online students.
Yes, we do. Okay. All right. All right. So number 3. Let's see. Okay. So what are the following variables is our categorical? So, do you want me to share my screen, or are you going to follow on your screen, or?
I can follow on my screen. Whatever works.
Okay.
I have my laptop and another monitor.
Okay. I'm going to try and see if I can get. Okay. Sorry, just trying to get a little organized here. Okay.
No problem.
And our video is over here. Okay. So which of the following variables is our categorical? So the number of animals in a local zoo, a randomly selected brand of toothpaste at a convenience store, age and years of a randomly selected vehicle in a parking lot, or A and B. So B, is that what you got?
I got B.
Okay. Number 4. I guess oh, are they a little different? I'm going to say if we just have the answers, we can just compare answers and just go down and fill it out. But, they might be a little different.
I put A.
Put the parameter was 100, right? And the statistic is 112, right? So what you got? Okay. So that was A and D then.
Yeah, is that what you got?
Yeah. Okay, number 5. I don't have to read them if you don't have to, but I don't know if they're the same or not. From the thing.
Yeah.
So
I think the same.
okay. So number 5, did you get stratified sample?
I put stratified. Yeah.
Stratified? Okay. Okay. Yeah, I just did that because they had to put them in or I guess I put stratified because then they could group them into each neighborhood and then pick randomly from the neighborhoods. That's how I figured it would be best to do that. I don't know.
Right.
Okay. Number 6, when design.
That's what I was thinking.
Okay. So when designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in the district. The experiment is then conducted using all the students in the selected class. Which of the following sampling scheme is implemented?
I put cluster.
Okay, was that number 6 on the?
But I'm not sure.
Okay, because if it is, then I put cluster too. So let me. All these millions of windows we got going on. Is it the same? Cluster. Okay.
Yeah.
Okay. And then 7, a school fundraiser. The name of every person who has attended entered into a drawing. At the end evening, 6 names were selected to receive door prizes, which is the sampling scheme implemented. What'd you put?
I put SRS.
Me too. Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100, and they took a list of Republicans and then a random sample which of the sampling scheme was implemented. I put stratified.
That's what I put too.
Okay. Yay, so far we're good to go.
Yeah.
Okay. A survey was taken of purchases at the Crossroads, opened the data file for Crossroads purchases, and then used the data to answer questions 9 through 11. So if those are the same questions or answers, then should we just be able to plug them in?
Yeah, I think so.
Okay. So for number 9, should be asking about the mean. What did you get for the mean?
4.771.
Okay.
Is that what you got?
Yep. And then number 10 is the standard deviation. I got 1.912.
That's what I got too.
Awesome. And then I did create a histogram. Okay. Okay. Now it's going on to the seal one, I guess. The one we had problems with. But we also have that together. So for A, we put, was that negative 0.165?
Yes.
Negative 0.165. And to put the negative, did you just use like the minus sign?
Yeah. Did you put a 0 too? 0.165?
I didn't, but I probably should. Okay. So 0.
I don't know.
Yeah. I think because of all the other quizzes we've had to put the 0, so I'll just do the 0. I'm not used to doing it that way, but I do. Okay. So negative 0.165. Okay.
Yep.
And then 13B, we put 0.681.
Yeah. Now for that one, this is probably a really dumb question, but when you calculate that, do you press the little square root button, or is it the exponent button?
To just square them, you push the x with a 2 for a square root. It does with the square root x. Is that what your question was?
Yes.
Yeah, okay. Yeah, so to square them, or when it asks for a square, that's the x with the 2 above it. Or the square root, that's the with a little box with the x inside. Or some have like the 2 outside of the square root of the box, but that just makes it 1, so it's the same thing.
Okay.
Anyway, that's calculus or something. Okay. So what quantity is equal to the sum of the numbers in the square deviations column? I'm going to go ahead and put the variance because I just remember doing the work when we had to calculate the variances and stuff, and variances, to me, I'm pretty sure that that's what it is, because I don't know, but Taylor said the sum of squares, which makes sense because that's exactly what it is, but we just haven't learned that term yet, at least not that I remember. So I'm going to put the variance, but if you can put whichever you feel. Or do you have a question?
Well, I put variance just because when I read over lesson 3 that defined variance, it just made sense to me, but
Okay. So we're gonna go ahead and put variance then.
okay.
All right. So then, what is the standard deviation of these temperatures? Round to the 3 decimal places. Okay, so all of my questions are wrong, basically, because I did it wrong with the mean. So then, to find the standard deviations, then we need to find the variance to then find the standard deviation, right?
Yeah.
I don't know. See, this is like where I was getting confused, what everybody else put, but I don't know. But I guess
The thing I did was just subtract the, I think it was the mean, the 0.075 minus 37.25, but now I'm not sure if that's correct.
maybe we'll just save that one for later. I don't know, because I don't know. I'll have to find the graph that I was going off of. But like that graph, there was other columns as well where we had to like multiply certain things. So that's where I got confused because it wasn't the same graph, but it was the same concept.
Okay.
I don't know. We'll come back to that and I can find the graphs later or whatnot.
Sounds good.
Okay. Under certain conditions, a standard deviation can be negative. And I looked that up and it said that standard deviations cannot be negative. So that would be why we square them.
All right.
So, and that made sense because that's why we have to square like our deviations. That's why we square them, so because they're that makes them not negative.
Okay, great.
Okay. Okay. And I think we talked about this one, 17, and we decided it was extradural, right?
Yeah.
Oh, wait. Which location result is the most consistent temperature? Yeah. Okay. And then I can define standard deviation in my own words, which is basically how spread out it is. If it's a big deviation, then that means that the numbers are really far from like 0 to 100. If it's small, then it's going to be like from 98 to 99, or it's going to be really close together. Is that pretty much how you describe it?
Okay. Yeah.
Okay. All right. The numbers of hours students spent studying. Okay, so 19 and 20. Okay. So what is third quartile 3? Is that asking us like what number it is at?
I think so. I put 8.
8. Okay. So I'd pick 2. And what percentage of the data lies between 4 and 8 hours? So we put 50, right?
Yeah, I just subtracted 75 from 25. Get that?
That's what I did before, but I don't know why I did that. Like 75 minus 25. And that's how I got 50 before, and then I was like, wait, why would I do that? I don't know. But I will just go with what she said, how she divided them all.
Yeah, that was a good idea.
That makes sense to me. So 50%. Okay. Now this one everyone confused the heck out of me over. 21. I know I totally guessed on this one, but somehow, this is how I did it, like without the group collaboration. I did the U sign plus 2 to the O sign equals 252. And then, although I don't really know because you still have two things to plug in, so I don't know how I got my answers.
The thing I did was I added 1.59 and 2.52, and then
I think it skipped out. So you added them, and then did you just divide them by 2 to get the mean?
yes.
Okay. So 1.59 plus 2.52 divided by 2. So you got 2.055?
Yes.
Okay.
To that during our group meeting?
Yeah, I think Corinne said that.
Okay.
Okay, so we have the mean. Now what do we do with that? Oh, I guess it's 21. Oh. Okay, so for 21, that's our answer, 2.055.
Yes.
Okay.
As far as I know.
Hopefully. Okay, and then our estimate, the standard deviation of the measured nitrate concentration in Rexburg's drinking water.
And the thing I did for that problem was I took the mean, which is 2.055, and then I subtracted 2. I'm not sure why I did that. Oh, because it says at the top of the problem, it says more than 2 standard deviations away from the mean. And then I divided by 1.59, but I don't know if that's right. So I got 0.035 for my answer.
Well, couldn't we use, so it gives us the equation U plus 2Q equals 2.52. So couldn't we plug in our mean and then solve for the Q or the O thingy, Q thingy, I don't know, whatever that is. And couldn't we,
Yeah.
would that answer the question?
That seems like it would make sense.
I don't know. I just don't remember doing that though. Or how would we do, could we use the 68, 95 something rule? Does that apply here somehow?
I don't know how that would get us this. I think maybe Matt said something about that too.
Yeah. Which I think that's what I was trying to do, but I don't know if I did it right. So yeah, I don't know what I did. Well, let's just go ahead and just plug in if we got our mean, and then we'll just solve for our standard deviation and see what we get. So we'll just do 2.055 plus 2Q equals 2.52, and then I'm just going to solve for the standard deviation symbol. So then we'll subtract 2.055. And then I'll divide by 2. And then, did you get 0.233 if we round to 3 decimal places?
Tell me again what you did. So you took the mean 0.55
plus, or I subtract. Okay, so to solve for the standard deviation, I have to get the deviation by itself. So then I have to do the opposites of what they're doing. to the other side of the equal sign. So to get, so if I use that equation to get 2.055 to the other side of the equation to get u, or the standard deviation by itself, then I have to subtract it. So I subtracted 2.52 minus 2.055, and I got, I don't know what I got because I already calculated the other number. So then that gives us our new number over there, and then so our new equation now looks like the 2 with the standard deviation symbol equals whatever the answer was that we got from their subtraction. Well, I could just do it really quick. It was 2.52 minus 2.055. So I got 0.465.
Okay.
And then to get the symbol by itself, since it's multiplying it right now, I got to divide it to move it to the other side to keep it equal. So then our new equation then looks like the standard deviation symbol equals, then I got 0.2325, so I'm going to round it to 2.33. And just for fun to see, that's right, I'm going to plug it into the other equation and see if I get 1.59. We'll just see if that works out. So let's see. Okay, so 0.233 times 2.466. And our mean is 2.055. And you get 1 point. Hey, you get the right answer once you round it up. So I'm going to say, if we solved it right, then it's 0.233. Did you understand how I did that? Although I don't know if it's right.
I got a little lost.
Okay, so are you good at algebra or not good at algebra?
I see how you got the 0.46. And so is that the not at all. Peter?
Wait. Can you say that again? It kind of sketched out a little bit. Sorry.
Are you doing the calculations on your computer? Can you screen share it, or are you doing it on paper?
I can do it on paper. Or I bet if I got out like paint or something, do you think that would work? Although
Probably.
So I have like a Windows, the new Windows 8 or something, so I don't know where they keep all those fun programs like Paint and stuff. Do you know?
I don't.
Okay. Let me just spend a few seconds, and if I don't find it, I'll just show it to you on my paper, although it might be a little confusing. So let me see if I can find Paint.
Okay.
Huh. Okay. Okay, so let's do screen share. Where's my Paint? Here it is. Okay, do you see that? Okay. So let me write out. So
not yet.
You see it?
Okay, I see it. Yep.
Okay. All right. So our mean was 2.055. I've not used this program in forever. 0, 5, 5, right?
Right.
And then the equation they gave us was plus 2q, right? Or that O thing. I don't know why I call it q. It's not a q at all, but this is what I call it. Equals, sorry, this is not very pretty. And then
No,
it's
it's fine.
2.52. Okay. So in basic algebra, we are solving for this symbol. Like, let's pretend that symbol is x to keep it simple. So then, if we want to get x, this by itself, we have to do the opposite of this, of what they're doing over here, to move it over here.
Right.
So that's why, so this right here is added on this side. So to move it over here, I need to subtract it. So that's why I subtracted the 2.055 here. 0.55. And so then our new equation, then we have 2q, or whatever standard deviation symbol is, equals, and then whatever the answer is. So 2.52 minus 2.055. And I got 0.465.
Okay. Great.
465. Okay, so then now this here is, they're multiplying this together. So like if it was 2x, that means it's 2 times whatever that number is. So since it's multiplying here, then we have to divide the 2 to get the symbol by itself. So then I divided by 2 here. And then now we have that the q is equal to, I'm sorry, I don't mean q, but whatever that thing is, symbol. So then is, and then I got 2.2325, but I'm going to round it up to 233. That makes sense?
Oh, yeah.
Okay.
Yeah.
Yay. So glad. Okay. So now whether that is how you're supposed to do this question or not, that's how I got that answer.
Okay.
So,
It makes sense to me because of that formula that they show.
yeah, we've never had to do that before, so I don't know. Maybe hopefully it's another way to solve the problem. I don't know. So, okay. So then, okay. Okay, now I don't know how to do my face again, but oh well.
So the answer for 22 is 0.233.
Yeah, that's what I'm going to put. It's probably wrong, but I don't know how else to answer that question. So, okay, so then between what two measured nitrate concentrations do approximately 68% of the data values lie? So this one we can use the 68% rule. Well, I guess we have to. But basically, what number is that? 23 maybe?
Yeah.
Okay, so my mean is different. And what, okay, so then I guess we just do that's where we have to do the u plus and minus the standard deviation times, I guess, 1 or 2 or 3, but 68% is just 1, so it's going to be the same, equals a number, I think. At least that's what I did on my homework, so I'm sure I looked it up. So then our mean was, so we got 2.055 plus the standard deviation, which is 0.233, and that should give us a number, and then we got to do 2.055 minus 0.233, and that's going to give us a different number, and that's going to give us our range. And then if it was like 95, we'd multiply our standard deviation by 2 or whatever number, but because it's 68, I think it's just 1, so it's going to be the same, right?
Yeah, I was doing a little bell curve drawing.
Mm-hmm.
So, I was just making sure I had the calculations correct. So, I got D for the answer.
Oh, snaps! I didn't even know they had the things there. Well, my answers are wrong because I had a different mean.
Yeah, I did too.
Oh, but it looks like it's going to work out because... So that means that we have to be on the right track then because our answers would be wrong, right? So I
Right.
got 2.288. Yeah. And that was the adding, so then the subtracting would be 2.055 minus 0.223. And that's 1.822. Sweet!
Mm-hmm.
Yay! So maybe we're on the right track here. Yay! Alright. What is the value of the mean of a standard normal, what is the value of the mean of a standard normal distribution?
And that would be 0, right?
The mean?
Yeah.
Oh, I think you're right. Is that like a rule or something?
Yeah.
Okay. Wait, are you sure? I'm kind of confused by this question.
I can go back and check. I think it's in lesson 3, but I'm not sure.
Oh,
But
it's 1. Isn't it 1? Because when you do the bell curve, or is that like different?
I think 1 is for the answer to the next problem.
Oh, I don't know. Yeah, if you can look those up, I don't know.
I can't remember where I found it, but I was yesterday or today.
Eesh, I don't know. Well, we can save those for later too and look them up and see what anybody else got maybe.
Okay.
That way. Okay, so 23 or 24 and 25. And do you remember what the other number that we skipped was?
I think it was 15. Or is that what you said?
I don't know. Dun, 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 dun. Oh, 15, you're right. Okay, 15.
Right. I just Googled the question we were just talking about, and it says the mean is 0 and the standard deviation of 1. So maybe I had it backwards.
Wait, the mean is 0?
Yeah.
And the standard deviation is 1?
Mm-hmm.
No, you had it right. That's what you said.
Oh.
I just don't remember reading that anywhere. I remember the 1, but I thought that was the mean. Because to me, like, how is the average 0? Like, that doesn't make any sense.
Yeah, I know what you're saying. So anyway, we can look at that later.
Yeah, I'll see what they say. But, I mean, if you got it on Google, well, maybe it's right. Because we all know how trusty Google is, right? Alright, and then... Okay, so this is the probability things that you had questions on. So I actually didn't know these either, and I found them. I wish I wrote them down where I found them. But I so remember where we're like, I thought we just had to plug in the top part, and that gives us the answer. But, yeah, so, but when I found it, and I was like, oh, you're solving for X, and I'm like, oh, yeah, I remember doing these problems. So, okay. So, we can work them over again just in case my calculations are wrong, because that
Great.
wouldn't be the first time. So what number is 26 in our homework? 20. What is the probability that a randomly selected student will score above 542?
It's 24. Number 24.
Okay. So what answer did you get?
I got 0.5.
I did too.
Oh, good.
So I did too. So, and it says, oh, and we only have to round to the nearest tenth, so that would make sense. 0.5. Okay. And then, what is the probability that a randomly selected student will score below 600 on the GMAT? Did you get 0.316?
I got 0.684.
Okay. Looks like we will be doing some math here. See
But you know what? On the next one, I got 0.316.
Oh, wait.
So below 600, I got 0.684. 600 or above, I got 3.16.
For the above?
Yeah.
Okay. Oh, wait. I have the same answer on two of them. What did you get for 25?
Below 600, I got 0.684.
Huh. So maybe I just did the math wrong on here. I don't know. Because I got the same answer for both. So minus, let me just redo it really fast. 452.3 divided by 54. Okay, did you get the or the z-score is 0.478 or 0.479?
0.479, yeah.
Okay, so I got that 0, right? So, do you have the applet up?
Yeah.
Okay, and then you did, okay, and you shaded below that?
Let me make sure. Yeah, I did them. Sorry, my voice is having a hard time.
You're okay.
I did the middle section and below. Was that right?
It should be because it's not negative.
Okay.
So, but let me hold up just a second. I do trust you. I just don't know how I got the wrong answer.
No.
So I don't know if I shaded wrong or what. So let's see. Okay, so our 0 was 0.479. And we wanted it shaded. We're asking for below, right?
Right, below 600.
Okay, and you got 0.684?
Yes.
Okay, me too. So I don't know. I guess I just shaded wrong. Okay, so so for what number is this?
That is 27.
Okay, so 0.684. And I guess should we put 0 on 26 for 0.5? 0.5?
Yeah. I almost forgot about that.
Yeah, I do too. Okay. And then what is the probability that a randomly selected student will score above on the GMAT? And then did you get 0.316 for that one?
Yes.
Okay, so I guess I just shaved above on both of them. My bad. Okay, so then I'll go ahead and put 0.316 on that one. Okay. And then 29 is find the score that corresponds to the 10th percentile round to the nearest whole number. So this is where we go to the applet. We'll put 0.10 in the top.
Okay.
Okay, well, make sure, okay, hold on, let me, because we want to make sure that we have it shaded before we put in the probability, or the percentile. We want to make sure that it's shaded to the left without going over the bar on the right. Does that make sense?
Mm-hmm.
So shade the middle and the left. And then put 0.10, and then we get a 0 score. And then how you decide between your z-scores is where they end the shading. So since the middle's not shaded, then we just go with the negative one. Does that make sense?
Okay. Yeah.
Did that make sense?
Yeah, it did.
Okay. And I read that in the reading, so that's how I know that, because before I did not. So then our z-score then is negative 1.282. And then now we have to plug that into our equation, right? So we gotta...
I thought we were done.
Oh, no. So this is our z-score, okay?
Okay.
So now we're going to use a z-score formula, but we're going to solve for x instead of solving for z, because now we have z, which is negative 1.282. So then by that number, put the equal sign, and then let's say on top of the fraction, we'll put x minus the mean, which was... The mean was 542.3, I believe. And then we divide it by the standard deviation, which was 120.54.
All right, so you have x minus 542.3 over 120.54.
Mm-hmm. And then that equals negative 1.282.
Oh, okay.
And then, so it's basically you're doing the opposites now to get x by itself. So since on the one side of the equation it's dividing the 120.54,
Mm-hmm.
we're going to multiply the 120.54 times the negative 1.282. So you're going to multiply those two together.
So I got negative 154.532.
You got... I guess I didn't write my answers down what I got. Let me see. So, sorry, 1.282 times... Wait. What'd you get again?
I got negative 154.3, I'm sorry, 154.532, and it's a negative?
Yes. That's what I got too.
Great.
And then, since on one side of the equation they're subtracting 542.3, to get it to the other side we're going to add it. So you're going to add to the number you just said, the negative 154.53228. We're going to add plus 542.3 to get x by itself.
Okay.
And then did you get 387.76?
I rounded to get 77.
Oh,
7.
yeah. Well, are we supposed to round 2 to 3, or does it say on our quiz thingy?
It says round to the nearest whole number.
Okay, so then that would be 3.88 then, right?
388.
380. Yeah, 388. Sorry.
Okay. You know, I do remember seeing this in our book now.
Yeah. So so now so to make this make sense, that means that in the 10th percentile, 10% of the people are going to get that number on their test.
Okay.
Does that make sense?
Yes.
Or 10% and below will make at least 3.88, I believe. So
Did
that's
you
how
get,
I had to tell myself.
are you doing 3.88 or 388?
I'm sorry, I keep putting the point. I meant 388. Sorry.
Oh, no
388.
problem. And so you do the same process for this, the next problem.
Yep. And it's only the 90th percentile.
Mm.
And I think this is where the shading starts to make sense and important, because when you do 90 percentile, it's the same z-score, only it's positive and not negative.
Okay. And it's shaded on the left and in the middle?
Mm-hmm. Yep. So that's how you know to use the right side, because they're doing everything below the positive number.
Okay.
I remember I found this and I was like, oh, I totally remember this now. It makes sense. Like, patted myself on the back.
That's great. So is x then just a negative 388?
I'm kind of confused by your question.
For the answer for problem number 30, is it just negative 388?
I got my answer is positive.
Oh,
Wait. For number
30 on the quiz.
for the 90th percentile, I got 696, and I got it positive.
Okay, because it couldn't be negative. That's right.
Yeah. So you do 1.282 times 120.54.
Mm-hmm.
And I got 154.53, blah, blah, blah. And then you add 542.3. Yeah, I got 696.832.
Okay. So the answer would be 697.
Yeah. I'm going to cry if we get like every single question wrong. We really shouldn't, but it's happened before, and I'm like, what? I thought I knew exactly what I was doing, and I got like a 70, and I'm like, what?
Oh.
But anyways.
Yeah, I do
I feel
that
like
quite
if we're
often.
doing, I feel like if we're doing getting the same answers, we should be on the right track. Okay, now 31. The first quartile of the distribution. Oh, we're finding the first quartile. First quartile, which would be Q1, which then is 25%. So we're doing the same steps, but we're just doing 25%, right?
Right.
Okay.
And so for this one, it's to the left. You shade to the left only. Is that right?
Mm-hmm.
Okay. Okay, I got 624.
Yes.
Good. Oh, you taught me something really good.
Yay!
Totally forgot about all this.
No, I did too. Because I remember we were like, I thought we just plugged it in and then that was the answer, but it didn't make any sense. We're like, what? And then they came to these questions and I marked them all that I had a question. And then I went back and I actually found them in the reading and I was like, I remember you're solving for X. Okay, makes sense.
Oh.
So, okay, so 32. Find the third quartile of the distribution. So third quartile is 75%. So then it's the same thing over again.
And so you shade the middle and the left again, right?
Well, I think if you keep your applet up, at least this is what I do. Once I do the middle and the end, then like when I first start out, then I think it automatically keeps it, so you don't have to keep doing it.
Okay.
It'll automatically do it by itself. So I only just worry about that the first time, and then I've never had to change it after. If that makes any sense. But yeah, if just to keep you safe, yeah, I just do the middle and the end, whatever's to the left of the right bar, the highest number. Didn't we just do 25% or 75%?
We did 9.
Oh, we did 25. Sorry,
Yeah.
I was confusing myself.
Do you think you'll take the exam today?
I think I might wait tonight for the other, if anybody knows how to do those ones that we didn't know how to do, and then I'll probably take it. Or if the teacher tells us how to do, like, those. Oh, I guess we kind of figured them out, huh?
I hope so.
I'll probably take it. See if anyone has any other whatever, but I'll probably take it today, yeah.
Sometimes I have to take quizzes and exams really quick after I finish studying, so I have it in my brain. It doesn't stay there very long.
Yeah.
I don't think I did this one right because I got the same number as the 25%.
I'm actually looking that up because for 25%, I was confusing myself. I actually went on to number 30. But 29, I got 461.056. So I think what happened, did you use the negative number? Because it's the same z-score, only one's positive and one's negative. So the 25% is shading on mine is the negative 0.674, and then for 0.75 is the positive 0.674. So I think you went ahead and did the positive one. So
yeah.
For 70, okay. So for those who are watching, so 31 is not 624, that is, I guess, 461. And for 75% is 624.
Okay, so for 31, what is the answer?
461.
And what was the issue with that?
You just used the wrong z-score instead of using the negative print. So go ahead and shade in your chart 0.25 in your applet.
Okay.
And does it shade all the way to just the negative number?
Yes.
Okay, so for 0.25, we use the number on the left because they didn't shade the middle, so you're going to use where they shaded up to. Does that make sense?
So you would fill in the middle too?
No. So when you put in, like when you put 0.25 in the applet, then it comes up with your z-scores, and it should be shaded only to the left of the lowest number, right?
Okay.
So because it's only shaded up to the negative number, that's the z-score you're going to use. And then let's say if I used 0.75, they shaved the middle too, so that means that they're using the positive one, not the negative one. So if the middle is shaded, you're going to use the positive number. If the middle is not shaded, it's going to be the negative number. Does that make sense?
Okay, yeah. So if the middle is shaded, use negative.
No, if middle is shaded, use the positive number.
Okay. Oh boy. Maybe I shouldn't take the exam today.
No, it's okay.
I'm kind of freaked out by it. Okay. And if the middle is not shaded, use the negative number.
Yeah. Because basically, a percentile, I read the definition, it said if something is like 10th percentile, that means that it's 10% and below. So when they're shading, they're saying that 10% of these people make this score and below. So if you're saying, okay, so 0.25%, they're saying the negative number and below. They make that. For 75%, they're saying you're using the positive number and below. So that's how you can figure out what z-scores they're using. Does that make sense?
Yeah.
Makes sense to me, but that's how I had to tell myself because I didn't but yeah, in the reading, yeah, I would, if it just doesn't make sense, I'd go read it in the textbook and maybe that will help you too.
Yeah, I need
crazy brain, it's crazy.
Okay, so are we on 33?
Yes. So consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of the sample mean scores for all such samples? So now this is getting into what we did, I think, last week when it was doing the population sample versus the sample of the sample, I guess.
Mm-hmm.
Or you have the general population and then you have the sample. And so that means that's when they said like the means were the same, but then the standard deviation for the sample, you have to do the square root and all that extra stuff. So for 33, I think it was just the same, right? So so was it 542.3?
That's what I got.
Okay. 542.3. And then the standard deviation, I went ahead and I did the deviation divided by the square root of 15 and round to the nearest 3 decimal places. So did you get 31.123?
No, I got 120.54.
Okay. Let's redo the math here because I seriously could be wrong too. So
what was the equation?
for the standard deviation, to find the standard deviation, you take the standard deviation, which they told us was 120.54. Because this is a sample, we have to divide that by the square root of n, which is 15.
Okay.
Do you remember that? Like if it's a sample of the large population, if they took a smaller sample. And so basically, this is how I say it. If there's an n, then it's obviously a small sample, so you're going to use the standard deviation formula of doing the standard deviation divided by the square root of n. If there's not an n, then it's just divided by the standard deviation because you don't have an n to square root. So that's how I kind of try to keep those straight. So square root of 15. Well, I guess with this calculator I can do it all together. Divided by
3.8.
31.123. Yeah, I got 31.123 again.
Okay, so you square that at the number 15.
Yeah. No. Square root it.
Oh.
So you'll do.
Sorry. So you do the little X with the 2?
With the box.
Okay.
Like the little square root box.
Okay. And so I got 3.8729.
Yes.
And then what do you do with that number?
Okay, so that number, so I write it in a fraction, so I'll put that number on the bottom of my fraction. So the 3.892, I put that on the bottom. And then you're going to put the standard deviation that they give us. So the 120.54, I put that on top.
Okay.
120.54. And then I just divide it. So I do 120.54 divided by the 3.892 number.
And you got 3113. Well, you got 31.131.
I got 123. And that could be because we rounded. That could be because so for 31.123, I didn't round the square root. I just did the whole number.
Okay.
So, and maybe we should do the whole number because that way it doesn't mess up our calculations for the quiz. I don't know. So if we did square root of 15, so I think I did the whole, like I did 3.8729833. So I didn't round up to the third. So basically, I think we're not supposed to round until the last step. because I've gotten a lot of questions wrong because I've rounded before that. So I think we just need to not round to the 3 decimal places until it's like the last step. It's a pain in the butt to write all those numbers down, but
yeah. Okay. All right, I got it finally.
okay. All right, last question, finally. All right, what is the probability that the sample mean GMAT scores for SRS of n equals 15 will be greater than 600? So, okay, so this wasn't really that hard because we already found the standard deviation. So I just did 600 using the z-score formula. I just did 600 minus 542 divided by 3 divided by 31.123.
Okay.
600 minus 3.
So I got 1.854.
Mm-hmm. And so now we have to plug that into our applet. 0.854. And it's looking for greater than. So we do on the shade to the right. And then I got 0.0319.
Okay.
Or I guess 0.031 or 32.
And it's just the right because it's greater than.
Right.
And so it's I got 0.0319.
Yes. But I think it's round to 3, so it's 0.032, right?
Yeah. I wonder what I did. I got the answer right, but I did something different. I didn't use, maybe I don't know what it is. But anyway. All right. So are you going to submit yours?
Well, we didn't do those other questions. We didn't know. What was it? The 15.
Oh, okay.
15, 24, and 25.
Okay.
So what was 15? Oh. Yeah. I'm going to see what they get for 15. And then, what was the other ones? 24 and 25? What were those? 24.
That was the mean and the standard deviation.
Oh, perfect. So it seems like I'm feeling pretty confident. I just got to go read up on those, find those charts that I was going off of and stuff. So I'll probably keep my answers for 24, 25. I just wanted to see what anyone else got or whatnot. And in case anybody asks, what you just, that was in the reading somewhere, right? Or no?
I'm sorry, what did you say?
For 24 and 25, you found those answers in the reading?
Yeah.
Okay. And do you know where you looked up, or like what lesson?
I was thinking lesson 3, but as I look in lesson 3, I don't see it. So maybe it's lesson 2 because it seems very basic.
Yeah. Okay. Awesome. So I'll save it for later, and I'll go ahead and stop the broadcast, send it to them, and then I don't know if I can copy my answers or not. Oh, I can. So I'll copy my answers and send them the email. This is what we got, and if they have anything that they got different or whatnot, then we can delegate from there. But yeah, I'll probably be submitting it if anyone can give any clarification on 15, and then we'll be done. But if not, then we only got like 3 wrong, so it's pretty good out of
Yeah.
30 something. So
Well,
all
thanks
right.
so much.
No problem, L'Oreal. We'll see you later.
Okay, see ya.
Bye.